Hey guys, welcome to GED Math Level 3 practice test. Level 3, basically there are 4 levels for our practice tests. So level 4 is the hardest, level 1 is the easiest. So this is the sort of hard one. What I would do is in the description are all 20 of our questions for this practice test, along with the multiple choice answer possibilities. So I would go ahead, if you haven't already, and take that test in the description, then watch the video, the explanation of how to do all the problems, as well as what the correct answers are. So that's the order that I would certainly recommend doing this in. From a scoring standpoint, you need a 145 on the GED to pass it. That is about 65%. So 65% of 20 questions would be 13 correct. So that would be kind of like the number that you want to get to, is at least getting 13. If you have some thoughts about college, it would help you out a lot to get a score more like 75 or 80%. So that would be more like 15 or 16 out of 20. That would definitely help you a lot in the application process. And also, we do have a mobile app that's free to install. The app will customize to you as you use it, so it'll send out recommended videos rather than you having to guess which video it is that you should watch to work on various topics. And it has detailed feedback for each of your questions. I think it's fun to use. As much fun as it can be while you're studying for the GED, at least. And so anyway, I recommend checking it out. Okay, let's get going. First question. It says Joe is on a 5-mile hike. Every quarter of a mile takes 7 minutes. If this rate is constant, how long to finish the hike? Okay, so let's see here. So we got 1/4 of a mile is 7 minutes, right? A lot of times I just like to write this stuff out so I can visualize it. Okay, so first thing is we'd like to make this into how long is it going to take us to do 1 mile, right? So if I multiply both sides by 4, then 1 mile is going to take 28 minutes, right? 7 times 4 is 28. And 4 times 1/4 is just 1, right? So then we're at 1 mile. And we're saying we're going 5 miles total, right? So then I just go take this 28, multiply it by 5, and that is 140. Okay, and so that's total number of minutes for the 5-mile hike, but they didn't do it in total minutes, they did it in hours and minutes. It's what we want to know, right? 60 minutes in an hour. So 60 times 2 is 120. So 120 minutes in 2 hours, and then add another 20 minutes on it. 2 hours and 20 minutes is 140 minutes. And that's our answer for this first question here. A batch takes 1.33 cups of sugar, 2.33 cups flour. Estimate total number of cups in 10 batches. Okay, so all you're doing here is we're going 1.33 plus 2.33 equals 3.66. Okay, and that's how many cups we have in one batch. So it can be confusing because you're getting cups from both the sugar and the flour, right? But that's what a batch is, right? So a batch is this 1.33 plus 2.33. Okay, and so then they want to know 10 batches, right? Okay, so we've got 3. Especially notice the word estimate, so it's probably not doesn't need to be exact. If we got 3.66 times 10, that's going to be, like somewhere around 36 and change, right? And so 37 is by far the closest here, right? So it's not quite 37, but it's a lot closer to 37 than it is to 30 or any of the other numbers, right? And so because of that, we will go with answer choice D, 37, as the approximate number. Okay, word problems. Probably get more requests for more word problems than almost anything else in GED math. If the gym is located 11 miles away from Dayan's house and the juice bar is 6 miles away from the gym, which of the following must be true? All right, so hold on before we're going to try to answer this. Okay, so this is Dayan's house right here. Okay, and then we have gym. So let's say it's like over here. Okay, and between these two spots is 11 miles, right? So the gym is located 11 miles away from Dan's house. The juice bar is 6 miles from the gym, but we don't know in which direction, right? So the juice bar could be here, right? So it could be here. So this is juice bar is 6 miles from the gym. So it could be here, right? Closer to Dan's house, right? And so this would only be 5 miles. So it could be that the juice bar is more or less like right in the middle, right? 5 miles from Dan's house, 6 miles from the gym. But it also could be that the juice bar is over here, 6 miles from the gym in the other direction, right? And a total of 17 miles from Dan's house, right? The 11 plus the 6. Either is possible. Okay, so having done all that, let's look at the question. Which one of these is true or could be true? Dan's house is at least 5 miles from the juice bar. Okay, so I would say that is true, right? Right? So if the juice bar is in the area like right here, closer to Dan's house, is we still know that it's at least 5 miles. So far I would say that one is true, but let's look at the others, make sure we don't have two answers that we like. Dayan's house is 17 miles from the juice bar. Okay, so that could be true, right? But they asked for must be true. Okay, so it could be over here, right? Little baby arrow, 17 miles away, but it also could be 5 miles away. Okay, we don't know, so we don't like that answer. That is not something that must be true. The gym is exactly 5 miles away from the juice bar. Okay, it says the juice bar is located 6 miles away from the gym. This says the gym is exactly 5 miles away from the juice bar, so no. Dayan's house is closer to the juice bar than the gym. Well, not if it's over here. Right? If it's over here, the juice bar is further away. If it's here, then that's true. So it's a maybe, right? It's another maybe, but they want to say must be true. And so therefore, the only one that we know must be true is answer choice A. That's what we're going with. Question 4. 12 pens cost $7.20. 16 pencils cost $4. What is the cost of 3 pens and 4 pencils? Okay, so they want you to get it down to what does it cost for 1 pen, what does it cost for 1 pencil, and then solve this problem. Okay, so 12 pens cost $7.20. So then that means we go like 7.20 divided by 12, and this is how we find out the price per pen. And if we do that math, that comes out to 60 cents per pen. Okay, and then do the same exact thing for pencils, right? So it was $4 for 16 of them. And if we divide $4 by 16, that comes out to 25 cents per pencil. Okay, and then we just have to multiply the numbers that we want, right? So they wanted 3 pens, 4 pencils. Okay, so all we're do there is we have our price per pen, which is 60, and they want 3 of them. So 0.60 times 3 plus the pencils cost 25 cents each, and they want 4 of them. Okay, and 0.60 times 3 is $1.80. 0.25 times 4 is 1, just exactly $1. We add those together, and we get 280. Okay, that is answer choice A. $2.80 total for 3 pens and 4 pencils. Question 5. The height of product X is directly proportional to its weight. If 2 feet weighs 40 pounds, how much does 60 inches weigh? Okay, and so sometimes like these terms, and like we're not used to thinking or hearing things like this, like directly proportional. So we'll talk about what that means in a second. So, but first of all, it says 2 feet weighs 40 pounds, and then they want to know about 60 inches. Okay, so we need to be comparing like terms, right? Comparing inches to inches. And so first thing we know is that 2 feet is 24 inches. Okay, each foot is 12 inches, 2 feet, 24 inches, and 24 weighs 40 pounds, right? So it's 24 is to 40 as, and then we just want to line the stuff up, right? And so then we know 60 inches is to X. Okay, and so when they're talking about directly proportional, what they're basically saying is this ratio of 24 to 40 that we have on the left-hand side right here, that ratio is going to be the same over here, okay, but just with different numbers. Okay, and so that's why we set it up this way, right? The 24 inches was in the numerator, the top part of the fraction, and so the 60 inches is in the numerator, the top part of the fraction. The 40 pounds is in the denominator, the bottom part of the fraction, and so this X right here is going to be some number in pounds, and so we put that in the denominator over here on the right-hand side. Okay, so we got it set up, and cross multiply. Right, 24 times X, that's 24X. 60 times 40 is 2400. Okay, and then if we just want to divide by 24, just to get X by itself, same thing here. And if we do that, 2400 divided by 24 is 100. Okay, so that means this is going to be 100 pounds. Answer choice B is what we want. And there we go. Okay, so that's how we set that up. Really the key there is just knowing how to set up the formula correctly. And then after that, just being able to crunch a couple numbers, and then we're good to go. Okay, let's see, question 6. Miller worked out 27 times this month. He's as fit as a fiddle. Miller always does only weights, cardio, or swimming. His ratio of weights to cardio to swim is 4 to 3 to 2. How often did Miller lift weights? Okay, so what we're doing here is like the key part to start with is the 4 to 3 to 2. Okay, so it says he only does weights, cardio, or something. So we care about weights, right? So weights is that first number, which is this 4. Okay, so let's start with that. Right. Similarly, cardio is that second number, which is 3. Swimming is 2. Okay, so he does weights 4 of 4 plus 3 plus 2. That's how you set this up. Okay, and so right now we're just trying to figure out like what fraction of the time does he do weights. 4 plus 3 is 7, plus 2 is 9. So 4/9 of the time he does weights, and that's how we figure out this little ratio here. Okay, now we go, and the question is how often did he lift weights this month, right? So he worked out 27 times. So we just go 27 over 1 times that ratio, or that fraction, 4/9. Okay. And we can reduce that even further. So 27 over 9, if we divide each side by 9, we can reduce to 1/3. Okay, and then 4 times 3 is 12 over 1, or just 12. And then the answer is 12 times. Okay, so if you haven't done a problem like this before, right, or it's been a long time since you did something like this can be very confusing about how to go after this question, but that's what you're looking at. At first, you're looking at the ratio, understanding that it represents, like 4 represents weights, 3 represents cardio, 2 represents swimming, right? And then you go and solve it from there. Okay, so if the question had been for swimming, then rather than 4 ninths, if say cardio, right? Since cardio is 3, if they'd asked you for cardio, then it would have just been 3 divided by 4 plus 3 plus 2, and so we would have done 3 ninths times 27. Okay, that's how you do it. Again, if that confuses you at all, one, leave comments for us, right, about where you're confused, and we will get back to you and try to give you more detail to help you out. Second, go into the app where you get lots of practice questions, and so you have to kind of understand the basic concept of how to do it, and then you need a bunch of practice doing it, right, to get good at questions like this and any questions that you struggle with, right? That's really the biggest value of the app, is just the number of questions and then good quality feedback for you, right? Doing that is really where we build up our knowledge, so that these things are no problem for us at all once we get to the test. All right, question 7. Hats offers buy one get one 40% off. Okay, so both the hats that John wants cost $15. What is the total for the 2 hats? Okay, so what we need to know is, what is 15 times 0.4? Right? 15 times 0.4, because the second hat is 40% off. Okay, so if we multiply 15 times 0.4, we get 6. Okay, and so what that means is the second hat is at a $6 discount. It was 15, right? And then 15 minus 6 is 9. So what we have is that first hat is 15. That second hat we just said was going to be 9, right? That $6 discount taking effect. 15 plus 9 is 24. There we go. Answer choice D. Okay, Susan borrows $20,000 at a simple interest rate of 9% for 5 years. How much will she pay in interest? Okay, so sometimes this wording can be a little confusing, right? And then it kind of sounds like it's 20,000 just times 9% once, and that will always be an answer choice, right? So I have 20,000. I'm going to multiply it by 0.09, and that results in $1,800. Okay, right, and so there's 1,800, and that really is just the number for 1 year. Okay, so whenever you see simple interest, unless it's just for one time period, like 1 year, so here the time period is 5 years, and so then what we need to do is take that 1,800 per year, multiply it by 5 years, and that results in $9,000. Okay, so not a very good deal for Susan, really, right? But making sure we understand that. Sometimes it will say 9% annually, which makes it a little bit easier for us to understand. But if it doesn't say anything, you just assume when they give you this for 5 years, that you're assuming that means 5 terms, right? Or 5 units, whatever, right? And so then you're going to have to end up figuring out what 20,000 times 0.09 is, then multiply it by 5. And in this case, it ends up at $9,000. Okay, percent change. Joseph put on 15 pounds of muscle this year. Last year he weighed 180. What was the percentage increase? That's the key word we're looking for. Percentage increase from last year to this year. Okay, so percent change. So this is a formula you need to know. Okay, this type of a question is going to show up. There's no stopping it. New minus old divided by old. If you think it's new minus old divided by new, you will get the wrong answer. Okay, and so what does this mean? New minus old divided by old. Okay, so last year he weighed 180, right? That's the old number. Put on 15 pounds, right? So the new number, what he now weighs, is 195. That's new. Minus old 180 divided by old 180. There we go. Now he's got to crunch a number, right? 195 minus 180 is 15. Carry that 180 down. Right, now we have 15 divided by 180. And if we divide that out, it ends up at 8. So it's going to be 0.0833 or 8.33%. The answer choice A. And there you go. Now, if you had made it new minus old divided by new, you had made this number right here 195, you would have got 7.7%. Okay, so they're throwing in an answer choice if you don't know the formula and you accidentally put in the wrong thing, give you an answer choice that is incorrect there. So anyway, got to know that one. New minus old divided by old. And there you go. We'll get to do it again if you didn't enjoy that one enough. Right? So this one is just percent decrease rather than percent increase. Same exact formula. New minus old divided by old. And if we calculate that out, we come up with a 44.4%. All right, moving on. 15 red, 9 blue, and 6 green balls. What is the probability that a green ball is randomly chosen? Okay, so this is part to whole. And we did a question similar to this, but not with probability. Okay, so we have 15, right, red, plus 9 blue, plus 6 green, right? So that totals 30, 19. 15 plus 9 is 24, plus 6 is 30. So there's 30 possibilities. Put that in the denominator. And the question is the probability of a green ball, right? We have 6 green balls. We put that one in the numerator. 6 out of 30. So if we divide each side by 6, 6 divided by 6 is 1. 30 divided by 6 is 5, and that's 1/5. And 1/5 equals 20%. Okay, if it wasn't obvious to you that 1/5 is 20%, you do this. 1/5 equals x out of 100, cross multiply, right? Because all these percent, when you look at a percentage, that's always out of 100, right? 20% is 20 out of 100. Okay, cross multiply, and so 5 times x is 5x. You would have 5x equals 100. You would divide each side by 5. 100 divided by 5, 20. So important skill to kind of have some of those division, multiplication skills where being able to divide 100 by 5 and things like that are fairly easy for you. That certainly makes a lot of this test a lot easier. So I would definitely be spending time there if that's any kind of an issue. Okay, next probability question. Deck of cards, right? This is also a very common probability question. Okay, so in a deck of playing cards, you have 52 cards, right? So 13 hearts, 13 spades, 13 clubs, 13 diamonds. We say after a card is discarded, meaning you can't draw that card again. Probability of 2 straight hearts. Okay, so whenever it's consecutive numbers, right? And so 2 straight is consecutive, is that means we multiply the probabilities together. So that's a concept that you want locked in your mind, right? Consecutive events means multiply the likelihood together. So for example, before we get to this one, if it was flipping a coin, right? So you have a coin, one side is heads, the other side is tails, and you said, what is the likelihood that I flip a coin heads 2 times in a row, 2 consecutive times, right? So it's 1/2 chance that I get heads, right? And it's 1/2 chance the next time, okay? So what's the odds that I got heads twice in a row? 1/4, right? What if it was 3 times in a row? And I just multiply it times that 1/2 again, right? Whoops. And that would get us over here to 1/8. Yeah. Okay, so that's consecutive events. That's how you do that. So I haven't answered this problem yet, of course. That was just a quick example with coin for probability and consecutive events. Okay, so in this one, okay, so they're asking about 2 straight hearts, right? So the first time my chance is 1 out of 4. So really you could say, if you want, because there's 13 hearts, it's 13 out of 52. But if you divide each side by 13, you get down to 1/4. Okay, so you start off with 1/4, and then the second, right? So the second time it would be 12, because there were 13 hearts, but now I drew a heart and discarded it, so now it's 12 out of 51, not 52, right? Because there's also one less card in the deck now. Okay, and I can cross multiply, or yeah, I can do this thing and this. So 4 out of 12 can be reduced to 1 out of 3, and then I'm left with 3 out of 51, right? And that's our final answer. Answer choice C. Okay, so that's how you do that. Again, the big concept for us is that consecutive probabilities means multiply them together. Okay, this is a tricky one. Right, the flipping coins was a little bit easier, but that's the concept. Multiply consecutive probabilities together. Okay, question number 13. Pemdas. Okay, you guys know Pemdas? You guys seen this? So the mnemonic is, please excuse my dear Aunt Sally. So it's just a phrase that represents PEMDAS, but what it really stands for is parentheses, exponents, multiply, divide, add, subtract. And so what that means is that's the order in which we solve problems, right, that have all these different operations, right? These are referred to as order of operations. We don't just go left to right like you would, like you think you would. Okay, so that means when we look at this, the first thing we want to look at is parentheses, and we leave everything else the same, right? So the 2 plus 2 is 4, right? So we'll just carry everything else off. So I got 4 squared here plus 3, and then I just do the parentheses part, 4 plus 10 minus 5. Okay, so I've done parentheses now, and I'll just kind of cross that off. Next is E, which is exponents, right? And so we got an exponent right there. 4 squared, 4 times 4 is 16. Okay, again, nothing else, right? Worst thing you can do is try to do these fast, right? Even if you feel like, no, I'm awesome at math, I can do it fast, I recommend not. Recommend taking your time following the PEMDAS. Okay, so now we've done exponents. What's next? Multiply. Right, and so you can see that 3 times 4 is 12. Right? I can multiply those two together, carry the rest of this junk down. 16 plus 12 plus 10 minus 5. Okay, multiply is done. Parentheses, exponents, multiply, divide. There's nothing to divide here, right? So we can not worry about D. Only got 2 left. And so now add and then finally subtract, right? So we can add all of these together right here. Okay, so 16 plus 12 is 28. 28 plus 10, 38, minus 5. 38 minus 5 is 33. Answer choice B. Okay. And if you didn't love that enough, we get to do one more. Okay, this one's a little harder. Okay, so again, first thing is parentheses, right? These will be on the test. Okay, you'll get one for sure. It's impossible to not get one. So we might as well be comfortable with it. Okay, so I changed nothing except for I just calculated that 3 plus 2 to be 5. Right, so we'll put that within the parentheses. There's a squared on there, and then divided by 5. Remember, not going left to right. Right, we're going in the order of Pemdas. I won't write it this time just because I think it's easy to remember from just a minute or two ago. Okay, so next we have exponents, and we've got 2 of them, right? So we've got 5 to the third right here. Right, 5 times 5 is 25. 25 times 5 is 125 minus 4 times 5 squared is 25. And then divided by 5. Okay, so we've done parentheses, we've done exponents. Next is multiply. All right, so right there, 4 times 25, that's 100. Keep everything else the same. Divided by 5. Okay, so we multiplied. And so here's an example where we got to remember PEMDAS, right? Because we've done parentheses, exponents, and multiply. Now we're dividing. So we do this 100 divided by 5 first, not subtracting, which you would think is what we would do, right? If you didn't know about PEMDAS. 100 divided by 5 is 20, right? And then all we're left with is 125 minus 20, and the result is 105. Okay, and that's answer choice D. Okay, so if, like, here's a decent example though, right? So if you look at where we were right here, if you had just gone left to right rather than using PEMDAS, then you would have gone 125 minus 100 is 5, divided by 5 is 1, right? And so you would have come up with an answer of 1 rather than 105. And then you would have looked and seen, wow, there's none, that's not one of the answer choices. It would be worse if it was, because then you would have picked it. But then you're like, well, what now? What do I do? You know, it's like you almost have to start over. Or just guess because you're not sure what to do. So anyway, remembering PEMDAS is a big deal. Okay, another small word problem where they want us to turn this into like a algebraic statement. If 13 is added to 1/2 of a certain number, the result is 37. What is the original number? Okay, so I just like to write this out, right? So 13 is added to. Okay, so I don't know what else they're going to ask me. I can't remember at least. Right, so I just have a plus 13 in here. And then the next thing it says 1/2 of a certain number. Okay, 1/2 of something. They won't tell me what it is, so we'll just call that X. The result is, so that's equals 37. Okay, what is the original number? Okay, so now we've set up the formula, and now we just need to solve, right? So if I subtract 13 from both sides, then I'll just have this 1/2 X by itself. 37 minus 13 is 24. Okay, and with this 1/2 X, if I multiply it by 2, that'll get rid of it, right? Because all I'm doing there is times 2 over 1, right? 2 over 1, 2 times 1 is 2, 1 times 2 is 2, so then I have 2 divided by 2 is 1, so it just makes it 1x. So that's all I did. I just multiplying by the inverse. And anyway, x is 24 times 2, which is 48. Answer choice C. Okay, 3/4 of the way there. 16. We got 5 questions left. what is the value of y when x is 1 and y equals 3 plus 2x? Okay, so they're just asking us to plug this x in. Okay, x is 1, and they're asking us for y, right? Okay, so y is 3 plus 2, and then they said x is 1, right? So I'm just taking this right here, putting it there. 2 times 1 is 2, 3 plus 2 is 5. That's all you gotta know. 17. Okay, prime factors of 42. Okay, so when they're doing this, so there's like the math way that you would, learn in school, and then there's just, we just want to get it right. So first thing is, with all these answer choices, when you see all these things, is these numbers, when you multiply them together, have to equal that. Okay, so usually we can eliminate like at least one, if not more, of the answers because they don't even multiply to 42, right? So regardless of whether they're prime or not, and whether they're prime factors, is they need to multiply to that. Okay, so let's start with answer choice A. 2 times 3 is 6. 6 times 7 is 42. 42 times 21 equals some huge number. So not that one. Okay, so we can at least eliminate this right off the bat. Okay, what about B? 2 times 3 is 6. 6 times 7 is 42. Okay, that one could be right. What about answer choice C? 2 times 2 is 4. 4 times 2 is 8. 8 times 7 is 56. No. Okay, so right, we've already eliminated 2. We haven't even looked at the last one yet. Answer choice D. 6 times 7 is 42. Okay, that's correct. Now, as we get into prime, right? So all except, so 2 is a prime number, but after that, no other even numbers are prime. So 6 is not prime. And so because 6 is not prime, we know the answer choice D is wrong. Okay, so without even knowing anything about prime factorization, we can get this one right. And you might think, well, this is just some example I made up to make this point. It's not true. It shows up a lot. But as far as prime factors, so is 2, 3, and 7. So if I would like to do this first to eliminate a few of the answers, but then we really go through the nature of 2, is 2 a prime number? Yes. 3, is 3 a prime number, right? And the answer to that one is yes. And then if it's a prime number, then is it a factor of 42? Okay, and the way you figure out if it's a factor of 42, you just take the 42 and you divide it by whatever number you're asking about, 3. And does this equal an integer, like a whole number, right? And so 42 divided by 3 is 14, so that one is good. What about 7? Same question, right? 42 divided by 7, what does that equal? It equals 6. So that's, again, an integer, so that works. So 2, 3, and 7 are all prime factors of 42. Is the only one that worked. We're happy with it. It's good to go. As much as any of the stuff that we've done here, prime factorization questions do need practice. And as I've mentioned before, the app is really the best way to go about getting that practice. But our videos are a great way to watch a few more of these problems being solved. So if you look for the prime factorization video, that's useful as well. Okay, greatest common factor, not that different of a question, right? So as you go through these, I would do the guess and check model and not go through the actual way to find these. Okay, so greatest common factor. So you're just trying to figure out, what they're asking you is, which of these numbers is greatest and is divisible by both 32 and 140. Okay, and then you just kind of go through it. So 32 divided by 2 is 16. 140 divided by 2 is 70. Okay, so you'd be like, okay, yes, A works, right? And then your only other question is, do any of these work? If they do, you'll pick that one because you want the biggest one that divides into both of them. That's what greatest common factor means. Okay, so what about 4? So 32 divided by 4 is 8. Okay, so it works for 32. 140 divided by 4 is 35. Okay, so that works too, right? And then you go and you do the same thing as you test it out for answer C and answer D. So it ends up 32 divided by 8 is 4, but 140 divided by 8 does not equal an integer. 140 divided by 16 also does not equal an integer. So a long roundabout way of describing this, answer choice B is the one that we want. Okay, Mr. Lewis plans to drive 900 miles, sorry, Mrs. Lewis, 900 miles to her vacation destination, driving an average of 50 miles an hour. Okay, how many miles per hour faster must she average to reduce her total driving time by 3 hours? Good question. This is tricky, but we are sort of at the end of level 3, so we're starting to see some harder questions here. Okay. Reduce the driving time by 3 hours. Okay, so first what we want to be able to figure out is how many hours did it take her when she was going 50 miles per hour, 900 miles. Okay, so when she went 900 miles at 50 miles an hour, how many hours was that? So 900 divided by 50 is 18. So it took her 18 hours. Okay, so the question is, how fast is she going to have to drive to get there in 15 hours, right? That's what they're asking you. Okay. So 900. So before we knew it was 50 here, because that was the miles per hour, right? To get to the 18 hours, right? Now we don't know what this number is going to be down here, so we're just going to call that X. Okay. Before it was 50, resulted in 18. Now, so 15 or 15 over 1 is really the same thing. Okay. And then if I go ahead and cross multiply these guys, then we'll know 15 times X is 15X. 900 times 1 is 900. 15X equals 900. And if I divide 90 by 15, I get 60. Okay, so she needs to go 60 miles an hour for 15 hours to get to 900 miles, which is her destination. Okay, and so the question though was how many miles per hour faster, right? So now she has to go 60 for the whole trip, where before she went 50. That's 10 miles an hour faster. Right there. All right, last one. If you're still with me, you're doing great, right? A lot of stuff to go through. St. Joseph High School has 402 people in their graduating class. There are twice as many females as males in the class. How many males are there? So just setting up the equation is a little tricky, right? And so what they're really saying is that 1/3 of the students are male. And what everybody, well, not everybody, but a lot of people make the mistake of thinking, and then they're saying how many out of 402 are male, right? So a lot of people read, when they see twice as many females as males, that they think this number should be 1/2 and not 1/3. But think about what it is. Okay, so we go and solve this. We'll put this over here. Okay, so twice as many females as males, right? So 2 female, 1 male. Okay, so if you have 2 females and 1 male, how many people we got? 3, right? How many males we got? 1. Okay, so that's why it's 1/3. Okay, so just kind of like thinking out what you're reading in math terms, right? That's all it is. Okay, so anyway, so we have 1/3 equals X over 402. Cross multiply, theme for this video, right? 3 times X is 3X. 402 times 1 is 402. Okay, so we'll divide each side by 3. And 402 divided by 3 is 134 males. Okay. And that was the question. How many males are there? There's our answer. Answer choice C. And we're done. Okay, so that gets us to the end of the level 3 GED math practice test. I hope this was useful for you. If confused on any of them, definitely leave a note in the comments. We're happy to respond and do everything we can to try to make this process easier for you and make your understanding of these math concepts at greater level and get you to the score that you want to get to. Besides just having taken this test, again, the kind of bottom line number that you're looking for is around 65% or higher, right? If you're below 65, we really need some extra work. And watching some of the other videos that we have that we'll have links to below the description will help you understand specifically what questions you missed and what videos you should watch. And then the other part is getting more practice, getting into the app. The app's really a lot more fun than listening to me. So I would recommend doing that. And answering questions is really the key part at getting better, right? So that's all I got for you guys. I will see you on the next video, and I appreciate your time.